All right. Bismillahirrahmanirrahim. So today we'll be starting the mixtures lesson. First of all, let's go into the summary. So first of all, you will be learning about types of mixtures. You can see. So under types of mixtures, there are several types, either homogeneous or heterogeneous mixtures, right? So we'll be learning about that. You can see the words homogeneous and heterogeneous. So then we'll go all the way down, and then now when we talk about mixtures, there are two words that we need to know: solute and solvent, right? So how a mixture is formed and what is in a mixture. So we have to learn these two terms under that. Then if we go all the way down, when you when you dissolve something, right, how good is it going to dissolve? Well, we are going to learn under the same topic, factors affecting solubility, right? So here there's an important point where you will be learning about organic and inorganic solvents, where you have the term polar and non-polar, right? We'll be learning all of it under this. Then comes the main second part, that is composition of a mixture. So there you have some mathematical calculations to be done, right? And then what are the instruments and so on. Here you will be learning about the concentration specifically, right? Mole per cubic decimeter is what the concentrations unit is, and so on. I'll be teaching you all of it today, inshallah. Then comes the third most longest part of the lesson, that is separation of compounds in mixtures. So how are we going to separate it? Again, it divides itself into two parts, where you have something called mechanical separation, right? Mechanical separation, that is like the physical stuff, right? And then you will be learning, yeah. So if I were to, yeah, mechanical separation, you have all of these. And then you will be learning for about, can you see this 3.2, 3.3? So all of these are other types of uh, separations, right? So how many will you be learning? You will be learning about a long list that goes on till 8 types of separations till chromatography, right? Chromatography, crystallization, recrystallization, distillation, simple distillation, fractional distillation, and so on, right? And then, so why do we need to separate things? Well, if you want something out of the mixture, you need to separate it. So, for an example, salt from seawater, right? So then the lesson comes to an end. Okay. So now you have an overview of the lesson in your head. Isn't it, Raida? You get an idea, right?
Yeah, miss.
All right. Okay. So what are the three parts for this unit, Puta? As I said you, mixtures divides into three. What was the last part? You have over here the separations techniques, right? Then you have the calculation part, calculation, right? And the first part is some terms and types of mixtures. Types of mixtures, and what do you have to learn? Some terms. Clear? This is the whole lesson, but it's a very long lesson. So you should have this map in your head. Clear?
Yeah, miss.
Oh, okay. I think I didn't share the screen. I was writing on the paint screen. Can you see the screen? The paint screen?
Oh, yeah, now it's visible.
Okay. Right. I was writing it, thinking that I have shared that screen. Right. Okay. Right. Now back to the textbook. All right. So let's go through this part then. So Puta, pay attention, right? I'm not going to go into every detail of it, because you might already have an idea about it, right? Because you have done this and at school, isn't it? Do you want me to go through very deeply, or I can just go through it and then go to the calculation part? What do you think?
Yes, the calculation would do because we did like
All of it.
on page 38 today. That's
Okay.
polar substances and stuff.
Okay, right. So you are okay with this part. No, then we'll go into the calculation part itself, right? Okay, where we'll be learning about composition of mixtures. Okay, Moaz is also here. So let's admit him. He will be just a listener. Okay, right. All right. Okay, composition of mixtures. So you said that you have done till here. Okay. So solubility of, okay, I'll come into this part where you will be learning about how well something is going to get, um, Raida, can you hear me? Okay, Raida, can you hear me?
Yeah, miss.
All right. Okay. So in this part of the unit, we'll be learning about solubility of a gas, how well a gas is going to dissolve in something. So the depending factors, right, how well a gas is going to dissolve is temperature and pressure, right? If you increase the temperature, it's going to dissolve well. If you increase the pressure, then again, it's going to dissolve well. For an example, look at this, okay, about the soda bottle, right? When you like what do we tell, if you are going to uh, how can I explain this, um as when you are going to open a bottle of soda, right, it's not easy, right? uh, it's pressurized. But once you open it, right, the carbon dioxide which was compressed in it gets released, right? Okay. So that's an example of how the solubility of a gas will depend on the idea of pressure, right? Pressurized carbon dioxide. If we drink carbonated drinks, right? So where they have this gas trapped in it. Okay, so that way, under pressure, the gas will be dissolved in the uh, liquid that we are drinking, the drink, right? Once you open it and you keep it, you left it open, what happens? The gas is going to come out and then you no longer feel the frizziness of the drink. You know about it, right? Have you all experienced that? An opened drink bottle, soda or cream soda, whatever the drink, the frizziness is gone once you open it and leave it for about maybe 2 days, right?
Yeah.
Yeah, so that happens due to this, right? The pressure is gone once you open it. Okay, so when the pressure is gone, the gas no longer dissolves in the solution, it just goes out. Once you pressurized, when they uh, close it for the first time, right? When they manufacture it, they pressurize it into the uh, liquid. That way, it will be stay dissolved uh, always until the lid is open. Right. Then the main part, the calculation part, composition of a mixture, right? So if you want to give the composition as a composition of mixtures as a mass fraction, M over M, this part, right? You have an equation, fraction of mass of A in a mixture, right? Now it's like this, but this is very easy. No need to complicate it, right? Moaz, you can hear me clearly, right? Moaz?
Yes, teacher.
All right. Okay. Uh,
Yes, teacher.
yes. No, Puta. I just wanted to make sure that you can hear me clearly. Okay. Right. So listen to me very carefully. Give me a minute, okay? All right. So if I tell you, that I'm going to have a, uh, um 50 grams of what shall we have? 50 grams of flour, right? 50 grams of flour and 50 grams of sugar. Okay, Puta. 50 grams of flour, 50 grams of sugar. So this is, if I want if you go back to the textbook, you can see it here clearly. Mass fraction of A in the mixture. So if I write it, the mass is measured in grams. Agreed? You know that already, right? Grams. So mass fraction of flour would be what, Puta? Flour is 50 grams. So if you are going to consider, percentage, right? How do you get the percentage? You have to get the total and how much is present in it. That is going to be the percentage, right? If you tell 20% is 20% of this sweet is chocolate. So 20% meaning if you take 100 grams of this sweet, 20 gram of it would be chocolate. That is what the mass fraction means. So similarly, 50 grams of flour, right, over 100 gram. So 100 gram, where did it come from? The total, of course, right? So did this make sense? Mass of A divided by mass of A plus mass of B. Let's imagine that you had three different substances. So that would make it mass of A divided by mass of A plus B plus C. Make sense?
Yeah, miss.
Okay, right. So look at this example over here, Puta. If they tell you to calculate the mass fraction of a solute. Now these two words you know, right? The terms are solute, solvent, solution. When you dissolve something of a powder-like substance, what do we call it, Puta? The solute. What you are dissolving, we call it as what? Solute. And what you have it in the beaker to get it dissolved. That's the word. What are you using to get it dissolved? You call it as a solvent, right? And both of these together, solute plus the solvent, we call it what, Puta? Solution, right? So if they tell you find the mass fraction of the solute, if they tell you to find the mass fraction of the solute from the solution, all you have to do is take the total mass. Out of the total mass, you have to divide the solute from the total mass. Look at the equation now. Mass of the solute divided by mass of the solution, right? Okay. Another example over here. They give you how much of salt is being used, right? And then they are telling you all the water in it evaporated. 100 grams of salt was left. Indicate the composition of salt in the solution as a mass fraction. So what did this sum tell you? I'm going to snip it, right? And then I'm going to do it as a sum that I have seen it for the first time, right? Without looking at the answer. Shall we try it that way? Look at this. Right. So they have given me this equation. Okay, look at, pay attention, okay? Because you are going to do sums alone today. Once I am done with the theory. So you draw a beaker. They have given you what, Puta? Solutions mass only they have given. So how much is it, Raida? How much is it?
To weigh 50 grams.
250 grams. And then they tell you evaporate all the water. So water is what, Puta, here? Water is the
Solvent.
solvent, right? So solvent is gone, they are telling. And remaining, they told something got remained, right? After evaporation, uh, that was, how much was it? 10 grams. So what is
10
this,
grams.
the 10 gram? The solute. What you were trying to dissolve, right? That is salt, basically. The salt is the solute here in sodium chloride. Indicate the composition of salt in the solution as a mass fraction. So what is the equation? Mass fraction of salt is equal to solute divided by mass of the solute. Solute mass divided by uh, the total solutions mass. Does this make sense? Does this make sense?
Yeah, miss.
Okay. So what is the solute's mass? 10.
10.
Yeah, divided by 250. You get 1 over 25 would be the answer, right? So how much would that be? 1 over 25. That is 1 over 25 would be 0.04. See if that is the answer. Yes, that is. Right? So you don't have a unit. You don't have a unit, right? For when you are talking about the mass fractions. So similarly, Puta, you can work on volume fraction. You can work with volume fraction. Same as mass fraction. In mass fraction, what were you dealing with, Puta? You are dealing with grams. In volume fraction, you will be dealing with what? Volumes, right? Cubic centimeters. Does this make sense? The mass fraction, the volume fraction.
Yeah,
Yes.
miss.
Yes. Okay. So we call it as V over V, M over M, right? So the same thing, only thing here, the difference is you are this time going to work with volumes, right? So let's do a sum. I'm not going to do it. You all are going to try it, okay? Let's take a worked example. Don't try to see the answer, right? Answer එක නැතුව screen එක බලලා උත්තරේ කියන්න බලමු පුතා. Rather work it out. What are they asking you? I'll give you 3 minutes. Work it out on a paper and let me know the answer. See if you can do it alone.
Done, miss.
Okay. Right. What would be the answer, Puta? What did you get as the answer?
0.1.
Yeah, 0.1. So all you had to do was divide 25 by 250, right? Okay, so back to the textbook. All right, you can see the textbook on the screen. Okay, so now look at the part 2 of it, where the sum continues. How do you prepare 500 cubic centimeter of an aqueous solution of acetic acid of composition 1 over 25 uh, volume fraction, V over V. So when they tell you the volume fraction, right, you can get the, what do we tell? If they tell you how much you're supposed to prepare and the volume fraction, all you have to do is multiply the volume fraction by the amount that you need to get how much of acetic acid will be in it. Okay, so I'll repeat that. So if you want to prepare 500 cubic centimeter of an aqueous solution of acetic acid, right, of the composition uh, 1 over 25, right, volume fraction, all you have to do is multiply the volume fraction by the aqueous uh, volume that you need, that is 500. Okay, so 1 over 25 into 500, you get 20 cubic centimeter. So what does this mean? This means that you have to take the total volume of your solution is going to be 500 cubic centimeter, and you're going to add 20 cubic centimeter of acetic acid, 20, right? Acetic acid, concentrated acetic acid, and then that will give you the, what do we tell? Uh, 1 over 25 V over V uh, solution. Does this make sense? Or should I explain it again?
Understood, miss.
Understood? Do you want me to repeat it again? Okay, what if I tell you that you want, this time you want 1000 cubic centimeter? What do you do, Raida?
1 over 25 into 1000.
Yeah, 1 over 25 into 1000, right? So to obtain that particular V over V, you are supposed to add 25 cubic centimeter of acetic acid, and you have to fill it till 1000, right? You have to fill the beaker till 1000. Then you have got the volume fraction of 1 over 25 of acetic acid composition solution. Okay, aqueous solution. Right. Now we've been working with grams, volumes. Now we are going to work with mole fractions. Right? We are going to work with mole fractions. Now mole fraction, again the same thing. Amount of when we talk about moles, right? Same as what we were doing before. Amount of moles of A divided by the total number of moles, right? If you have a mixture of A and B. Okay, so let's look at the worked example over here. Right. what is the mole fraction of sodium hydroxide in a solution made by dissolving 400 grams of sodium hydroxide in 180 grams of water? Now, first of all, Puta, firstly, you're supposed to find out how much of mole is present in 40 grams of sodium hydroxide. Do you agree?
Yeah.
Yeah, right? Okay, so if I ask you the now over here, what have they given you, Raida? They have given you the what are these? The
The mass.
masses. So if I in case if I tell you cutting this and if I tell you mass fraction, the sum is way too easy, no? All you have to do is to get the mass fraction of sodium hydroxide, 40 divided by 180. Do you 40 divided by 100 and 220? Make sense? But
Miss, how did I get 220?
180, you have to add it, no, Puta, the 40.
Ah, yeah.
You
Yeah.
forgot. You forgot it, right? So total mass එකෙන් පුතා බෙදන්න ඕනේ, right? But here you are not you are not asked for the mass fraction. You are asked for the mole fraction. එතකොට පුතා ඉස්සෙල්ලා මොකක්ද ඔයා කරන්න ඕනේ? First of all, you're supposed to find the number of moles, the amount of mole in both of these. Okay, so I'm going to, I can't quite write in here because there's no space. So I'm going to snip it and put it on my paint screen so that I have enough space to work. Take it away. Put this back over here. Right. So what the firstly I have to find out to get the mole fraction, Puta, you need the amount of moles, right? Amount of moles. Do you agree?
Yes.
Yes, but I don't have the moles here. I have only the grams. So from the grams, you are supposed to get the moles, right? So let's work on that now. Let's work on that now. Sodium hydroxide. I need the mole number, but I don't have it. Only thing I have it is, it has 40 grams. I have 40 grams. But I know an equation that I have learnt in grade 10. N is equal to M over M, isn't it? Right? I know the number of moles. Yeah, I can calculate the number of moles if I know the mass and the molar mass. Well, the molar mass, even if they haven't given you, you can calculate it easily, Puta. This is given. The molar mass, can you calculate? Can you get it? Yes, you can get it. Because you know sodium is 23, right? And by the way, let's go back to the textbook and see if they have given it to you. No. මේ වගේ සම් එකක් දෙදි පුතා මෙතන එක්සෑම් එකේදී ඔයගලන්ට මෙතන වරහණක් ඕපන් කරලා දෙනවා සාමාන්‍යයෙන්. Sodium 23, oxygen 16, hydrogen 1 කියලා දෙනවා. Okay, so you don't need to worry about those values. So sodium hydroxide, what would be the this one, Puta? The molar mass 23 plus 16 plus 1. Do you agree?
Yeah.
So how much is that?
40.
40. So 40 grams divided by 40 grams per mole. The molar mass, the unit, okay? Grams get cancelled for grams. 40 divided by 40 is 1. So 1, this mole minus 1 goes up. It becomes 1 mole. So in 40 grams, there is 1 mole of sodium hydroxide. Okay, right. So you got that number of moles. You found it. That is 1 mole. Okay, now let's work out with water. Water I know only the mass. They told me it's 180 grams. So I know the equation. N is equals to simple M over capital M. Simple M, the mass is given 180. The molar mass of water is how much, Puta? Water. 2 hydrogens and 1 oxygen. How much is that?
So 18.
18. So 180 grams divided by 18 G mole minus 1. Okay? G gets cancelled for G. So this is, how much is it? 10
10.
mole. So I know water. How many moles does 180 grams have? 10 mole. Now, back to the question. What did they ask you in the question? They want you to find the mole fraction of sodium hydroxide. Okay. Now I know in this particular container, I have 1 mole. I have 10 mole of water. And I have 1 mole of what, Puta? Sodium hydroxide. So I can now tell the mole fraction of sodium hydroxide, isn't it? Is equals to
Yes.
1 over what? 1 over?
You have to add all.
Yes, we need to add all. So how much is it?
28.
Why put
Is
the
it?
28? What are you trying to add here? You want to add only the number of moles, Puta. Okay, let me zoom this thing out and
Miss,
okay.
I'm a bit confused with the mass and the moles and stuff.
Right. It's like this, no, Puta. Then, අපි මේ කරලා තියෙන්නේ මෙතන, they started off with the mole fraction, right? In order for you to find the mole fraction, Puta, let me show it for you. Why did I come here? Because I want to show this equation. The fraction, the mole fraction. Let me take this to here. Look at this equation, Puta. A. The mole fraction of A is equals to amount of moles of A divided by amount of moles of A and B. So the total number of moles, right? Okay. But they listen to me very carefully, okay? They tell you to find the mole fractions, but they don't give you the mole numbers. They give you the mass. So if they give you the mass, from the mass, you are supposed to find the number of moles. Does that make sense, Raida?
Yeah.
So they give you the mass. Ta balaganna. They tell you to find the mole fraction. In order to find the mole fractions, what do you need, Puta? Mole fraction එක හොයාගන්න නම් ඔයාට ඕනේ amount of moles, right? Mole amount or the number of mole you need. But you read the question doesn't have the amount of mole at all. The question have grams. So what are you supposed to do? They give you the gram, right? Mole amount only you need, but the mole amount is not found. But they give you the grams. So, okay, but you don't need to be sad about it. Why? Because from the gram, you can find the mole amount if you know the molar mass. If you know the molar mass. Now, does this make sense? Raida?
Yeah. Miss.
Okay,
Yeah.
so what is your duty now? What are you supposed to do now? From the gram, and the molar mass, get the mole amount. Okay, gram is given. This is given. Let me write it in red maybe. Gram given. So if you want the mole fraction of sodium, I'm going to do this. Give me a minute. Copy. And I'm going to paste it down here. Why I'm rewriting it twice, you will understand. If you want the molar fraction of sodium hydroxide, you need the sodium hydroxide molar mass. Okay? And if you are in need of the H2O's mole fraction, you need to find the H2O's molar mass. Right? So that is what we have done here. This 23 plus 16 is this. And this 18 is water's molar mass. Right? In order to get this, I divide this by this. I divide this by this to get this. So that is what has happened here. Does this make sense, Raida? This is red
Yeah.
and this is green. Okay, H2O mole number. Now you tell me the mole fraction of sodium